Hi everyone, very good evening and welcome back to Geeks for Geeks practice. Please give me a +1 if my voice is clearly audible to everyone and everything is working fine. Currently it's raining in northern India, so the light is not coming. Okay, so please give me a +1 if everything is working fine. Hi Vanchika and hi Rishit as well. So please make sure to hit the like button, guys, and I'll quickly share my screen so that we can discuss the problem as well. So let's share the screen and see. Okay, so I hope that the screen is getting shared. Right. So today's problem of the day, like basically yesterday's problem of the day was really interesting. It was asked in JustPay, right? So this problem was asked in one of the online assessments of JustPay. Okay, and let's quickly discuss this problem. It basically you can say that it was a graph problem, but you did not require any graph knowledge for doing this problem, right? So can we start? Please make sure to hit the like button and give me a +1. Then I'll start with this problem as well. Okay, make sure to hit the like button as well, guys. Okay. So basically in this problem, what you have to do is you will be given a maze. Okay. So basically you'll be given an array, right? That will be of n size. So basically this array, let's say, has been given to you that is containing n elements inside it, right? So this array has been given to you, which is containing n elements inside this. The size of this array is nothing but n, right? The name of this array is nothing but the edge. Okay. The name of this array is edge and it has entries inside it. Now the problem says that each cell may have multiple entry points, but not more than one exit point. So we'll discuss that further. Now let us say that if this kind of an array has been given, so let's say we have been given something like this. Let's say we have been given 2, okay, then we have been given 0, then we have been given what? We have been given -1, and then we have been given 2 again, let's say. Okay, if this particular thing has been given to us, so let's say this is the edge array that has been given to us, right? If this is the edge array that has been given to us, and let's talk about the indexes as well. So let's say these are the indexes. So let's say this is index 0, index 1, index 2, index 3, right? If this particular array has been given, so there's a line in this problem statement which says that the edge I contains the cell that can be reached from the ith cell in one step, right? So basically this says that the problem says that if this index is 0, right? See, if this index is 0, right, and this index is 0, right, and this is what, this is edge of 0, this is nothing but edge of 0, right? So basically what is happening here is, like, from 0 you can reach 2. Okay, from 0 there is a path going towards 2 here, right? This is the meaning. Like if the index is 0 here, and at this 0 index I'm having this particular element which is nothing but 2. So basically this indicates that, okay, 0 is having an edge towards 2, right, inside the graph. Now after that, if you will proceed further, so if you will look at this particular indexing, make sure to hit the like button, guys, if you haven't already. I can see a lot of people are watching us, right? After that, if you will look at the next index, so next index is 1, and 1 is having this entry 0, right? So at this index, like in the inside this array, edge of 1 is what? Edge of 1 is nothing but 0. So basically what is happening here is, like, 1 is having, you can say that in this answer also you can see basically what is happening. This indicates that index 1 is there and it is having 0 and 0 as the entry. So basically 1 is having the edge towards 0. That is what is indicated here. So basically what happens, like, 1 will have an edge 0. So let me change the color of the pen, right? So here we can say that 1 is having an edge towards 0, right? Because we can basically say that index is basically having an edge towards this thing, right, towards the entry that has been given. So basically if this array is named as I, let's say, so I is having an edge towards array of I. That is the thing here. Is that clear to everyone? To be very simple, this is what the problem says. Is that clear to everyone, guys? I hope that my voice and everything is clear. Is this point clear to everyone? Please hit the like button if you are clear till this point, and give me a +1. Is that clear? Basically, this ith index, like, ith index is having an arrow towards RFI. That is what the problem statement indicates us, nothing else, right? Then after that, if I'll proceed further, right? So in this case, I can say that afterwards, let's look at the next scenario. So if we will look here, so basically this is 2 and it is having -1, right? So basically this indicates that this particular index is having the value as -1, right? So here the edge value is -1. So basically it indicates that 2 is not having any edge towards anybody, right? After that, if I'll move to the next index, right? So please write -1 in the chat. For 2, if it is having, if any edge, like if any index is having the entry inside the array as -1, so it indicates that there is no edge going towards from this index 2, right? Now after that, if you will look forward, so we have 3 and 3 is having 2 inside it, right? So basically there is an array going from 3 to 2, right? So indirectly you can say that, let's change the color of the pen, right? So basically you can say that from 3 you are having an edge towards 2. Is that clear to everyone? Is that clear to everyone, guys? Please tell me. So this is the you can say this is the graph that is developed here. This is the graph that is developed from this given information. If you will see here, so you can see that one is having an arrow towards 0, right? Then you can see that one is having an arrow towards 0, then 0 is having an arrow towards 2, and then 3 is having an arrow towards 2, right? So that is the whole scenario. Now what you have to do here is, what you have to do here is, you have to tell that, okay, which is the maximum weighted graph, right? Maximum weighted node, right? So basically, what is the weight of a node, right? What is the weight of the node? The weight of the node is nothing but the number of edges, basically the weight of the node is nothing but the weight of the edge that is coming towards it, right? So see, basically if you will see here, so what is the weight for 0? Like let's say that we have we have an array which stores the weight. So what is the weight of 0? So which edge is coming towards 0? Can you tell me? Which node is having an edge towards 0? Can you tell me? One. Please write one in the chat. Okay. Which edge is having, can I say that towards this node 0, right? Can I say that one is having an edge towards it? Yes, one is having an edge towards it, right? So since one is having an edge towards it, so and no other node, so basically I can say that, okay, the weight is 1, right? That is the scenario. Okay. Now what is the weight of this node 1, right? What is the weight of 1? So can I say that the weight of 1 is nothing but can I say that the weight of this node 1? So for this node 1, is there any edge coming towards it? No. Please write no in the chat. Is there any edge that is coming towards 1? No, there is no edge coming towards 1. So since there is no edge coming towards 1, so the weight of this is 0, right? Then after that, if I'll talk further, so what is the weight of this node 2? Can you tell me, guys? What is the weight of this node 2, right? So can I say that the weight of this node 2 is nothing but the edges that are coming from those nodes, right? So 0 is having an edge towards 2, okay, and 3 is having an edge towards 2. So basically the weight of this node 2 will be nothing but 0 plus 3, which is nothing but 3. Is that clear? Please write 3 in the chat, or plus 1 in the chat. Is that clear to everyone, guys? Is this point clear to everyone? Right. So this is nothing but 0 plus 3. Right. Now if I'll talk about, okay, that what is the weight of this node 3? So I can say that, okay, the weight of this node 3 is going to be what? There's no edge coming towards 3, right? So the weight of this node 3 is nothing but 0. Okay. Now which is the node with the maximum weight? Which is the node which has the maximum weight? Anybody can tell me which is the node that is having the maximum weight? Can I say that the node that is having the maximum weight is what? This is the maximum weight, right? This is the maximum weight, 3. And which node is having this weight? 2. 2 is having this weight, right? So basically 2 is the node which is having the maximum weight, right? So that is why the answer will be nothing but 2. Is that clear? Is that clear to everyone? Is this much point clear to everyone? Please tell me, guys. I hope that everyone is clear till this point. Is everyone clear? Okay, a lot of you are writing 2 in the chat. So please hit the like button, guys, if you are clear till this point. So please make sure to hit the like button, and then we'll proceed further as well. This much point is clear to everyone, right? So basically, as I said, let's say that if we are having this edge array, right? So as I said, let's say we are having this edge array. So basically, if I is having an edge towards edge of I, that is what is indicated here, right? If you will see this array, so if I'll make this again, let's say that this is the entry. So one, 2. Let's say this is 2 0, and then this is minus 1, and this is 2. So basically, this index is what? 0. This index is nothing but 0. So 0 is having an edge towards 2. So I is having an edge towards edge of I, right? So can I say that? Can I say that for this guy, right? For this guy 2, right? Basically, edge of I is what? Edge of I is this particular value, right? This is nothing but edge of I. Now, can I say that the weight, if this is the scenario, so I can say one thing very clearly that let's change the color of the pen here. Okay. So I can very clearly say that, okay, the weight of this edge, right? Since 0 is having an edge towards 2, right? So this is, let's say this is I, okay, and this is edge I, right? This is edge I, right? So for this 2, there is additional weight, that is 2 that I'm having, right? Or in fact, if you will see, let's take another entry here, right? Let's say that if I take this entry, this particular entry, so this index is what? This index is 3, right? This index is 3. So it indicates that, okay, 3 is having an edge towards 2, right? So if 3 is having an edge towards 2, so basically this is I, okay, this is nothing but what? This is nothing but the I thing, right? Index, and this is what? Edge of I. Okay, this is edge of I, right? So I can say that for this guy too, which is edge of I, right? For every edge of I, it should get added with I, because I is having an edge towards edge of I. So basically, what will happen? Edge of I plus is equal to I. Is that clear? Plus is equal to I. So I should add this weight of the ith edge, because since I is having an edge, since I is having an edge towards edge of I, right? So that is why what I will say is, if I is having an edge towards edge of I, so basically for this edge of I, that is for basically, let's say for this node 2, if 3 is having an edge towards 2, right? So for this 2, the weight should increase with this value I, right? Because if I is having an edge towards this guy 2, right? If 3 is having an edge towards 2, so 3 should be added in the weight. Is that clear to everyone? Please write clear in the chat. Is everyone clear with this particular point? Everyone, is that clear? Please give me a plus one if everyone is clear with this point. Is everyone clear with this idea? Basically, I is having an edge towards edge of I, right? So basically, for this edge of I, that is nothing but 2, right? So I should say that, okay, the weight of this 2, right? The weight of this 2 should get added with 3, right? So basically, I should say that, okay, weight of edge of I, right? Edge of I, right? For this guy, it should get incremented with I, right? That is what I'm saying. Could you please repeat the scenario again? Okay, I'll try to repeat it again. Right. So see, if this scenario has been given to us, so if you will look here, right? So I have to calculate the weight for every node, right? So if you will see at this scenario, let's say these are the indexes. I'll change this again. See, these are the indexes. Let's say this is index 3, right? This is 0, this is 1, this is 2. So 3 is having an edge towards 2, right? So in this case, what will happen is the weight of 2 should get updated, right? Should get updated with 3, okay? Because 3 is having an edge towards 2. So the weight of this node 2, if I am a person, right? If I am there, okay, and let's say somebody else is having somebody, let's say somebody is having an edge towards me. So basically that, like, I'll add this guy's weight. If somebody is having an edge towards me, if somebody is coming to me now, so they will bring some chocolates for me, they will let's say bring some toys for me, they will bring something for me, right? If somebody is coming at my home, so they will bring something for me, right? They will bring some gifts for me. So that is the thing, like, if there's an edge coming towards me, so that is why I'll add them in my weight. That is what the problem states. So basically in this case, I can say that, okay, the, like, if this ith guy, okay, if it is having an edge, like if it is having an arrow towards edge of I, right, in this array, so basically I'll say that, okay, weight of edge of I, right, weight of edge of I plus equal to I. So basically I'll add this I, right? And in the end, whichever has the maximum weight, that I will consider. Is that clear to everyone? Is that clear? Like, so for every node, I'll calculate this weight, right? For every node, I'll calculate this weight thing, and whichever node has the highest weight, that I will be printing in the end. Is that clear now? Is that clear to everyone? Please give me a plus one, guys, if it's clear. Then I will proceed further. Okay. So I hope this point is very much clear to everybody, right? Okay, so basically what we can do here is, let's zoom in a little bit more. Right, so what I'll be doing is, I'll be having a array, right? So I'll be having a vector that will be storing the weight. So let's say that we'll name it as weight only. So we'll have an integer array that will be of size n, and it will be storing the weight. So let's name it as weight. And for all the n edges, basically initially the weight will be 0. Please write plus 1 in the chat. Initially for all the edges, the weight will be 0. Is that clear to everyone? Initially for all the edges, the weight will be 0, right? Initially for all the edges, I'll keep the weight as 0. Then what I will do is, I'll say that, okay, let's run a for loop. Okay, so for int, let's say I starts from 0, I is lesser than n, right? And I plus plus is what I'll be doing. Then I will say that, okay, if there is an edge going, right? So I need to check that if the edge of I is not equal to -1, okay, because if it is not equal to -1, then only there is an edge going, right? If edge of I is not equal to -1, then only there is an edge going from I to edge of I, right? So if there is an edge going from I to edge of I, so in that case, what will I do? I'll say that, okay, the weight of edge of I, right? The weight of this guy should increase by I. Is that clear to everyone? Is that clear to everyone? Guys, till this point, everyone is clear? If there is a edge between I and edge of I, then in that case, if there is an arrow going from I to this guy edge of I, right? This guy edge of I. So let's say if I is 2 and there is an arrow going towards 3. So basically, let's say I is 3 and there is an arrow going towards 2. So if there is an arrow going towards this guy 2, so basically the weight of 2 should increase by. So basically I should say that, okay, in that case I'll say that, okay, weight of 2 plus is equal to 3, right? So that is what I am doing here, right? Plus is equal to 3. Is that clear? All of you are clear? Please give me a plus one, guys, if everyone is clear with this idea. Till this point, everyone is clear? Uh, okay, please tell me and hit the like button as well if you are clear till this point. Is everyone clear till this point? Right. Then what I'll be doing is, I'll say that, okay, int, I will like after that I'll have the answer variable. So let's say initially I'll mark my maximum, right? So maximum can be marked as, let's say, int minimum, that is negative infinity. Okay, and I'll also have answer variable. So initially, let's say I'm marking the answer as 0, right? In case if it does not exist, so I'm marking it as 0, right? Answer is the node that I'll be returning that has the maximum weight. So the answer is containing that thing, right? So I'll say that okay, I starts from 0, I is lesser than n, then I'll do an I plus plus, and what I will do is I'll simply say that okay, if it happens, right, that the weight of this ith edge, right, if it is greater than, like I'll say that okay, if it is greater or equal to, right, maximum, in that case what I will do is I'll say that okay, answer is equal to this ith node, and my maximum weight will get updated to weight of I. Right? Is that clear to everyone, guys? Is this point clear to everyone? Right? And then I'll simply return this answer. That is the node that has the maximum weight. Is that clear? Please give me a +1 in the chat, guys, if you are clear with this point. If there's somebody who's not clear, please let me know. Okay, is everyone clear? If you're clear with this point, please hit the like button. And if there's something that's not clear, please let me know. So basically, what I'm doing is I'll initially store the weight for all the nodes, right? So if there's an edge going from I to edge of I, so basically the weight of this node edge of I will be increased with I, right? After that, I'll mark the maximum as int min, right? And then I'll say that okay, answer is equal to 0. Like basically, if it does not exist, so answer will store the node that has the maximum weight, right? So see, you will think that okay, if the weight of the ith node, right, you will think that okay, normally a person will think that okay, if the weight of this node, right, if the weight of this ith node is greater than the maximum weight that I have seen so far, right? So in that case you will say that okay, answer is equal to I, and the maximum weight is nothing but weight of I. Yes, right? Yes or no? Please tell me, guys. But in this problem, if you will see, so they have also stated this particular statement that if there are multiple nodes that have the same weight, in that case, you need to return the node with the highest index, right? So let's say if there's a scenario like this, let's say there's an array, okay, and let's say 2 is having, right, let's say the weight of this node, let's say for example, let's say the weight of this node 2, let's take this example, okay, let's say the weight of this node 2, okay, it is equal to, let's say, 5, right? So let's say the maximum is also 5, right? So maximum will be updated to 5 and the answer will be updated to nothing but 2. But what will happen, it should be, yes, it should be this thing. Why it should be this thing, that is why I'm telling. So let's say now if the weight of 3 is also 5, right? So in that case you can see that I am basically iterating from 0 till n minus 1, right? So I'm running a loop like that. So basically now if this guy is also having the same weight as the maximum weight, let's say the maximum weight is 5, and this guy is also having the weight equal to the maximum weight, right, greater equal to, so it is having the weight that is greater equal to, right? So in that case I should update my answer with this node, right? So my answer should now store, instead of storing 2, it should store 3, because if 2 is a node, like if 2 is having the weight as 5 and 3 is also having the weight as 5, so I should store the higher node, right? I should store the node with the higher value. That is why I'm writing this condition that okay, if weight of any ith node, if it is greater equal to mx, right, the maximum weight, if it is greater than the maximum weight, then it's fine. But even if it is equal to, so since I'm iterating, since my I value is always increasing, so if I value is equal to 2, okay, and I value here is equal to 3, so I should take this I, if this is the maximum weight, that is 5, and this weight is also 5, so if this is even this is equal to the maximum, right, this weight is equal to the maximum, but this I value will be higher, so that is why I'll update my answer, right, I'll update my answer here, right, answer will be updated to nothing but the ith node, and my maximum weight will be updated to weight of I, right? So my maximum node will be updated to weight of I. Is that clear to everyone? Please write clear in the chat, guys. Is everyone clear till this point? Please let me know. I hope that everyone is clear. If you are clear till this point, please make sure to hit the like button, guys. Is everyone clear with this point? If you are clear, so please make sure to hit like. Okay, is everyone clear till this point? So that is what I need to do here. So let's scroll down a little bit, right? So you need to write equal to here as well. That is why. Okay, because every time the I value will keep on increasing, right? Now let's try and compile this code as well. Okay, so it says that I was not declared, so let's declare this I as well. If maximum possible way to then return the higher, if multiple possible, then return with the higher index. Yes, that is what we are doing now. If the weight is, if the ith node is having the weight greater than mx, then you will store it. But even if it is equal, so even if the weight of the ith node is equal to the maximum, even then you will store the new I. Why? Because that I will be higher compared to the previous I. If the previous I was 2 and it was having the maximum weight, but now when I will be equal to 3, okay, then even then if it is having the same weight, So you will store this I. You will store answer as 3 now. Why? Because it is a higher I. You need to store that uh, node which has the, if there are multiple nodes that are having the same weight, so you'll store that node which has the highest value. Is that clear? Individual value. Let's try and compile it. I hope it will work. Let's see what happens. Right, so this problem gets accepted. Is it clear to everyone, guys? Is it clear to everyone? Please tell me. Is that clear? I hope that everyone is clear with this problem. Please make sure to hit the like button, guys. If everyone is clear, is everyone clear with this problem? I hope that each and everyone is clear with this problem, right? Uh, okay. So I'll just request you to hit the like button if you haven't already. Talking about the time complexity for this problem. So as you can see that I'm running one order of n loop for calculating the weight, right? So let's quickly summarize the time complexity and the space complexity. So what I've done is, if I'll talk about the time complexity, so basically I'm running one order of n loop, okay, for calculating the weight, right? For calculating the weight array. And similar, like Kavita, the same thing you can apply in Java. Similar approach will be there. Only you will use an array list, nothing else. Same thing will be done in Java also. Like you, instead of having like vector, you will have array list. Nothing else is going to change. If you want the solution in Java, so you can text me on LinkedIn if you want. Okay. So then another order of n I am taking, right, for calculating the answer. Right. So the overall complexity is still order of n. And talking about the space complexities, so I am taking order of n size, space complexity. Why? Because I am storing the weight, right? I'm taking a weight array, so I'm storing this particular thing, right? And this is the thing. Now this problem was asked in the online assessment, right? It was asked in the online assessment, I think, of a company which is nothing but JustPay, right? So this problem was asked in the online assessment of JustPay as a coding question, right? So that's the thing. Is that clear? So this is the first time that I'm solving a JustPay problem on GOG. Is that clear to everyone? Okay, if you're clear till the end, so make sure to hit the like button. Okay, and share this video with your friends as well if you have some peer groups. And make sure to subscribe the channel. I'll comment down understood or +1 after this video is over as well. And is there any question that you are having? I hope that this problem was pretty much clear to everyone. Okay. So Naikaj says that if multiple nodes, yes, if there are multiple nodes with the same weight, then you'll consider that node which has the highest value. So if, let's say, there is a node 2 which is having the weight as 5, and there's another node 3 which is having the value as 5, so in that case you will consider the node 3 because it has a higher value. Can we go with without extra space? So if I'll look into this problem, so I think that you have to take extra space for solving this. So I don't think that you can go. If there's any solution that you can definitely suggest that in the comments as well. Okay, and thanks a lot, Mohit, as well. So Rishit says thanks. Uh, Thanks a lot, Kavita, as well. So make sure to hit the like button, guys, if you haven't already. Okay, Mohit gives a +1. Thank you, everyone. And make sure to solve the problem of the days regularly. And before ending, I'll still suggest that if you have understood everything till the end, so make sure to hit the like button. Keep coding. Thanks a lot. I'll see you in another live. Till then, bye. I'll see you on Monday. Bye, everyone.